Hello, quick video on pair testing and statistical testing and its benefits. I decide that I'm going to find out who can run faster between me and Usain Bolt. And I decide I'm going to run on the cinder track and I do my 100 meters in 20 seconds. I know that surprised you, Charlie, but that's what I did. Meanwhile, Usain Bolt has to run through a swamp and he can't fly over the top of it and he gets stuck in it. It takes him 50 seconds to do his 100 meters. So I'm faster than Usain Bolt. Isn't that right? No, it's not. So how do we fix it? We do pair testing because pair testing eliminates other factors. In this case, the other factor was the ground, and what we were interested really was the speed and strength of the two athletes. So I'm going to take us through an example of a drug testing, which is a classic one, and how we use that to eliminate other factors. Okay, here's an example I'm going to use of testing an asthma drug. And what we're going to do is we're going to use the same people and we're going to test the effect with and without the drug. In this case, they're either going to take the drug or they're going to have a placebo, and we're going to measure the difference for that person. So we will get their perception of how effective the drug is on the placebo for 1-to-1. Yeah, one person, which one they think's better. So we're going to use 12 individuals, 12 subjects, and they're all susceptible to asthma. Yeah, so they're all in the same sort of place. They could have slightly different susceptibilities, but we're going to compare their susceptibility. Then we're going to give them the drug or the placebo after separate asthma attacks. And then 1 hour after the attack, we're going to get them to complete an index assessment for each person and see what their perception is of the effectiveness of the drug or placebo. So a lower score, an index, a lower score means better. Yeah. So for subject number 1, they have an asthma attack and we give them the drug, and their perception of it is they give it an index value of 28. On another occasion, they have an asthma attack and we give them the placebo, and their perception of its efficacy, its benefit is ranked at 32. So this person thinks the drug is better than the placebo. Yeah, and they've ranked them 28 to 32. The second person, second subject, well, when they have an attack and we give them the drug, they rank it as effectively 31. It's an effectiveness, and if they give them the placebo, they rank their sort of condition afterwards as 33. So again, they think the drug is better, but you see they've got different rankings, 28 and 31 here, and 32 and 33, but both of them are saying that the drug's better than the placebo, and it doesn't matter what their ranking is, it's the difference we're going to be interested in. And the third subject, well, they think the drug made a lot of difference because they ranked it as 17 compared to their placebo at 23. And we could go through. The fourth person thinks it's better as well. If we carry along, we get to the 8th person who doesn't think it's any better, he thinks it's the same, or the 7th person who actually thinks that the drug is worse than the placebo. And we can do that for every person in our trial up to the 12th person who thinks that the drug is better than the placebo and ranks them 17 and 24 in their index. So what we're going to do is we can take out this relative view of pain and index because we can just look at the difference. So let's do that. So the first person, the first subject, ranked the drug at 28 and the placebo at 32. So if we take the difference of those, we get -4. So that's their perception, is that it's some sort of benefit, and they've ranked it, the difference as 4. Next person ranked the difference as 2, benefit of 2. Next person ranked the difference as a benefit of 6. Sorry, they're different. Yeah, they gave us a difference. Yeah, and we can carry on through to the 7th person who didn't think it was better. They thought it was +3, so they thought the placebo was better. The 8th person is no different. And the 9th person thinks it's a benefit again. So here's our differences, and now we're going to head off into our Wilcoxon testing, just as signed rank testing as we did before. So what do? We've got to rank all this data, and I've put a couple of little nurglies into the ranking for us to think about in this different sort of method. So for number 8, when we get to the ranking, the first one is that the subject number 8 thinks they're the same, so it's neither positive or negative, so we're going to discount their score, and we're not going to include that in our sign rank testing. And then we're going to start ranking from there. Well, the closest in is number 9, thinks the only difference is only 1. Then there's 3 people here who think that the difference is 2, the 2nd, 10th and 11th. And we've got to share out their ranking because they're effectively equal, aren't they? So rather than having a 2nd, 3rd and 4th ranked person, we have 3 people all ranked together, and we've got to share out their ranking. So we had 2, 3 and 4, that adds up to 9, and we're sharing it between 3 people, so they all get the average ranking of 3. Similarly, there's 2 individuals here who both scored the difference as being 3, plus 3 or minus 3, and in our ranking that counts the same. So here we've got our 5th and 6th person, so we average those out and they get a ranking of 5.5. Okay, and we go all the way up to the last person's ranked 11 because we've discarded number 8 from our set, so we've only got 11 people rather than 12 now. Yep. And then in our usual Wilcoxon, we then sum up those with a negative difference, the rankings for them. So that's the 7, the 3, the 9, the 11, the 5.5, the 8, the -1, the -2 and the -7 here, so they become the 3rd, 3rd and 10th at the end there. So we add up all those rankings and we get a value of 57.5. And if we added up all the positive ones, those people who think the drug made them worse, we'd end up with the 5.5, and the 3 would give us 8.5. And if we add those 2 numbers together, we get 66. And again, we can do a manual check to see we've added them up correctly, because we've got 11 people. Then adding 1 to 11, we're going to get the formula is 11n, n plus 1 over 2. That's 66, tick. So we've added them up correctly. Okay, so now we're going to use those 2 Wilcox statistics against our hypothesis. And our hypothesis is there's no improvement, i.e. the value is the same, or there is improvement, in which case the value is less, so it should be a less than sign there. Okay, we got our 2 values we've calculated. For the people who think it's better, 57.5. For people who think it's worse, is 8.5. That's our sign, the sum of our sign ranks. And as we're going to find our critical values from our Wilcoxon table, we take the lower value because that's what our Wilcoxon table is going to do, of 8.5. So that's my test statistic, 8.5. My score could only be between 0 and 66. Think about it, isn't it? It could all be favourable or all be unfavourable. And our H0, our expectation would be that our score would be about 33 if there's no improvement, because 33 ranks points would be above and 33 below our 2 values. Rather than being 57 and 8.5, they would be 33 and 33, wouldn't they? Okay, then we need to get the critical value from the Wilcoxon table. So here it is in the MEI tables. We have a sample size of 11 now, so we're coming down the first column till we get to the row with 11 in it. Remember, we had 12 items and we discarded 1 because it had no difference, so there's our 11. Then we need to decide, well, we had a one-tail test at 5%, so we need to decide which column that is. That's going to be one tail 5%, so that's the first column, so I can come down and see the intersection of the first column with the row with 11 in, and I get a critical value of 13. So going back to my diagram here, my critical value is 13, and therefore my critical region will be between 0 and 13. And we've already established that our test statistic is 8.5. So our test statistic is in our critical region, so the result is significant and H0 is rejected. And we can say there's sufficient evidence to conclude that the drug is effective. So here's my little summary as ever at the end. So pair testing, the benefit is when we're carrying out our test, We're doing that for the same person, same people or place or time, and we're doing it for the with or without the effect we're testing. So in this case, it was a drug. It was either the drug or not the drug, and we're testing the results for both of those situations with the same people, and it eliminates other factors. So if we use the same people, we can ignore the fact that they might have different genetics or fitness or diet, or in our case, perception of the benefit, or because it's a subjective perception ranking. It's not a sort of a specific and measurable one. We could alternatively look at a place. So for example, if we were looking at traffic and the setting up of the traffic lights at a particular corner and adjusting the timings on it, there would be no point in doing it at two different places, would there? You'd want to do it at the same place, and you may well want to do it at the same time of the day. And that's the other thing we might want to measure is we might want to be doing everything at the same time of day, because we might want the same temperatures. It wouldn't be fair to compare, a situation when it's really hot with when it's really cold. So for example, if you change the tarmac on a road and the braking distances, well, the grippiness is going to be different in the freezing cold than it is in the warm. So you'd be measuring it at the same time of day, so you get the same temperature, wouldn't you? So we do that to eliminate other factors. So that means we need to be clear what we are looking for, what's the factor we're looking for, and then we get that we're testing, and then we eliminate factors that we're not testing for by matching the circumstances. And then for each person or subject, we work out what the difference is, and we're using that as our test data. And then we put the results, that test data, either into sign testing or Wilcoxon testing, and we see what the results are. So there you have it. That is pair testing. Hope that's of use.